All right, if everyone wants to get settled, we'll get started. Okay, welcome everyone. My name is Dimi. I am a project officer and drone pilot at Landcare Australia. And as land carers, we all know the significance of weeds. So we have Freney here to talk about harnessing AI and aerial imagery for scalable weed detection in Australian landscapes.
Hey everyone, how are you? So I'm Freney. So I'm the Business Development Manager for the Centre for Invasive Species Solutions. So I work in the... Got the tune still playing? Oh, perfect. Nailed it. That was just the intro, everyone. I had that on purpose. I work as the Business Development Manager, and one of those projects I work on is WeedRemeed, which, as the title says, harnessing AI and aerial imagery for scalable weed detection in Australian landscapes. So for those of you who don't know, the Centre for Invasive Species is a research, development and engagement organisation, not-for-profit, focusing on invasive vertebrate pests and also the weeds as well. So, yep, I'll jump in. And so what is WeedRemeed? So WeedRemeed is an AI machine learning software system. It's cloud-based and it's been designed to process data at large scale, so looking to be able to map landscapes as opposed to small areas. It uses a couple of different techniques. One of those is colour swatching, which uses, it's basically a comparison of colour to the drone imagery to something you design, which I'll touch on later. Machine learning is using texture and shape, and that's basically training a model on a bunch of examples of the weed to then be able to map, once again, process and map out at large scales. So the software has been developed by 2Ply Software, and at the moment it's really focused on that drone-acquired imagery. But it has been designed and developed so that way, moving forward, it can be used to process different data sets as well. It just needs a bit more investment to change in that one. But we're focusing on just drone imagery at the moment. So how it works, so we fly a drone. Depending on the quality of the camera really defines the drone survey instructions. So if you have a fantastic camera, you can fly higher. If you have a specific or a lower quality camera, you'll need to fly lower to make sure that you get the quality of the imagery. So for example, a Mavic 3, that's looking to fly at about a 40-metre height, and then you'll have good quality imagery to then be able to process through the system. So this is the first technique. Oh, there's the spotter there. And this is using the colour swatch system. So I'll touch on a few different colour swatches moving forward, but basically it compares a coloured image which you create to the drone imagery that you acquire. So we're processing still images as well. So we're not doing a video, we're processing a bunch of still images taken across the landscape from a top-down view. So then we process at scale, and then we geo-reference all the weeds that are detected based on that. And this is pretty much the raw data that's processed out, which is these boxes around, so that way you can do that quality assurance as well to make sure that it is actually detecting what you want it to detect and not detecting other species that you're not interested in. So moving forward, how does this help? Well, the geo-reference data can be used to guide how you're undertaking your control system, whether that be on ground or moving into input into spray drones. So that's the end goal, basically, is to really guide how we undertake our control. So this is how the colour swatch system works, and the other side of it is the machine learning image annotation. I don't have a fantastic grid like I did before, but this is how it works. So we, or the user, will annotate the images and provide examples of the weed to the system to train the model. So this is where it's using that shape and texture, and that's how it basically processes the imagery. It's a comparison to the data set. So when you are annotating images, you would like to have a variety of different settings, a variety of different contrasts, so that way you can have the best outcome when you are processing all the imagery through that model. So we want an annotation of a minimum of 2,000 plants. So we need a large data set to train the model. Otherwise, you'll have a lot of variability and inaccuracy in it. So it basically, at the moment, we're using a VGG annotator, and you just click and drag over the species, and then you label it with that one, like that Parkinsonia there. So I'll now touch on, I guess, one of the key things, which is a great feature of WeedRemeed, is that it's sovereign safe data. So it's data is collected and stored in, or data and code is hosted in AWS Sydney Data Centre. So it's stored in Australia, which is a huge thing for going for different grants and different projects, is that you need to make sure that your data is secured, and this system is secure. It adheres to the highest Australian standards. WeedRemeed does not own or keep your data. When you join into WeedRemeed, it is a secure space. So this is your space where you have control of your data. You can choose to share it with people, but you can also keep it under your own space, so that way it's yours. As that says, you can make it fully public, or you can share it with specific individuals, or keep it to yourself. If you withdraw your data, mechanisms to remove all traces are in place, so there's no lingering data storage or anything like that. So at the moment, the WeedRemeed system is currently functioning under a Saving Native Species grant, so that's how the project was really developed. And we've just finished all our trials, so that's what I'll be talking about in a little bit. But the objective was to develop new tools to mitigate the impact of broad-scale threats on threatened species. And intended outcomes is to reduce extinction risks for priority species, improve habitat condition in conservation areas, and support at-scale weed detection. So our trial site selections was selected with various collaborations, so Bush Heritage, Nature Foundation, Consignia Environmental, and ACT Parks. Sites were selected based on ecological significance and conservation priorities. So it was really guided from our steering committee about what species we were targeting and where we were going to undertake these drone surveys to test the system. So the trial site location, so Spring Valley Farm, ACT, that's where we're looking at Patterson's Curse. Buckrabannual was Wheel Cactus, Urambi Hills, St. John's Wort, Edgebaxton Reserve, we looked at Parkinsonia and Solanum, and Bullock Bridge Reserve was Coastal Wattle. So the drone flights and parameters, so we did test a few different flight heights and flight speeds, and getting a few different GSD pixel sizes. So a lot of work has been done, not only in our project, but in a project in New South Wales as well, about that sort of what quality, what resolution of imagery are you wanting. So a key where we're sort of ending up is that 1 centimetre / pixel is what we're really wanting for the quality of the resolution to have the best outcomes. When you start going above that is when you start having issues with basically the quality of the data and the detection rate of the system. So with Bullock Bridge, we did a bit of like a test, I guess, to test the capacity of the WeedRemeed system. So that's where we flew the drone at multiple heights and at different angles around the plant species. And that provided us what we sort of expected was that if you train a model on a various data set, it's not going to be very successful. So the trial site locations and size, oh, sorry, I hit the back button. Perfect. So this is what I keep talking about with the color swatch images. So this is what they actually look like. So it is literally a pixelated image of color to compare your data set to. So if we look at a couple of species here, we've got St. John's Wort, which has a yellow flower, which is why it's got that yellow sort of color in it. Parkinsonia, a green sort of color, which is what there was no flowering species at the moment. Solanum adoxum, which was green as well. And then we've got Patterson's Curse, which once again wasn't flowering, so it was still that sort of coloured of the actual leaves, and Wheel Cactus, which is just a plain green one. So I guess you can see issues with the colour swatch system straight away. If you're comparing a green Solanum adoxum on a green grass background, the colour swatch system isn't going to be useful for that plant. But if we're comparing a yellow flower here to a green background, it's going to be successful, which is what that St. John's Wort was. And Wheel Cactus is a cactus. The background is pretty dry and it's basically a brown background. So Wheel Cactus had great success as well. Patterson's Curse did have some success with it, but once again, having a purple flower would have really helped to identify the individual species, which is where the issues became. is identifying the individual species with the colour swatch system. So the Solanum odoxum, an issue with that, once again, was that colour background. It was very swarmed, so it didn't